introduction to the project. I will tell about what Aligned set out to do, why we're doing what we're doing, and some of the results. Then we will have a case study of Damien Arbeau about bio-based.
Animatrice, je lance un appel à mes amis.
If it would be English, I would have been able to understand it, but if you,
I could understand.
Okay, good. Yeah, Damien will tell something about our case study. We did a case study, and there were quite. We used some of the new methods we developed in Aligned, and Damien will tell all about that. And after that, we will have an interactive discussion where we will hope to show some results of a survey which we did earlier. And we would like to gather your feedback, which you can give via your phone. So have your phone at the ready so that we can have some nice interactive part there. This is about the introduction. And we can now go to the introduction to the project, which is still me. So you're stuck with me for this moment. I hope my screen is visible, Rachel?
Yes, we can see it.
Thank you very much. Yes, some general information about Aligned and the project, and of course us ourselves. My name is Patrick Reumerman. I work for BTG. BTG is an SME located in the Netherlands. Our main focus is the to energy and materials produced from biomass, the production of that from biomass. And then within that specialized subject, we are quite broad. We think ourselves a unique combination of consultancy, R&D, and project development. And that means that our people who give advice to industry players and governments know about the latest development from R&D, and our R&D people know what is happening in the market. We exist for more than 25 years, I think 30 years now. Many projects, many plans realized. 10, 20 years ago, we worked mostly in developing countries. Nowadays, we work mostly in Europe and in the Netherlands. We span the entire chain from pre-feasibility to implementation, the project chain. And also our expertise spans the entire value chain from the biomass, the availability, the feedstock, quantities, pre-treatment, to conversion to sales application in the market. We have extensive knowledge on gamma aspects, as we call them, things like the sustainability of biomass and biomass application, life cycle assessment, value chain evaluation. We do financial analysis, feasibility studies, of course. We know a little bit about legal aspects. We are also active in knowledge transfer work. We do this not alone. We do this often with partners. We have experience with the formation of consortia, and we very much like to cooperate with others in larger European projects, of which the Aligned project is one of them. Well, Aligned, how did it happen? Aligned, it came across because we were working for the European Union in a study where we looked at biorefineries and how the policy could be changed to stimulate the growth of biorefineries in Europe. And one of the things that we were investigating there were the barriers towards bio-based products and applications. And we interviewed many stakeholders, and we found that lack of evidence on sustainability is a problem by many stakeholders, is seen as a problem by many stakeholders. And we found not just one problem, but various problems. One of them is that it's costly. And to prove the sustainability, you have to conduct LCAs on a product level. So if you have a lot of product levels, a lot of products, you need a lot of LCAs. They are sometimes open to interpretation. There's no level playing field with fossil competition. There are many labels and standards, but they are not always effective. And the methods are sometimes sector specific. The Higgs MSI for textiles, the EPD for construction. So this leads to a confusing terminology. So yeah, quite some problems. And we thought, well, we should try find ways to improve that. And there was a call for the European Union, from the European Union to look at ways to improve the environmental sustainability in industrial bio-based sectors and to improve the gathering the evidence on that. So that was very nice that this opportunity was there, and we took it. So we submitted a proposal, and we have established this Aligned project. And the idea of Aligned is to integrate the 5 bio-based, industrial bio-based sectors. You see them here: construction, woodworking, pulp and paper, textiles, and biochemicals, and improve the environmental sustainability of those sectors and how to measure it. Because all these 5 sectors, they share the biomass resource. They are quite different in some aspects, but also quite similar. So we would like to align them there. Our objectives are thus improve, harmonize, and align the LCA methodology for the assessment of bio-based industries. We want to demonstrate the power of the methodology. So we have case studies in these sectors, one in each sector. And we want to do inform, involve, and empower stakeholders to enable an efficient methodology uptake, and of course to improve the methodology itself. We do this not alone. We work as partners. We work with a number of universities. One of them is the INSA Institute in Toulouse, of which Damien is an employee. We have 5 sectors, so we have 5 case study companies, 2 research SMEs, B2G and Sustainable Innovation, and 1 sector organization, which is Centex Bell, and you can see from the logo, it is from the textile sector. Then, what have we done so far? We are near the end of the project. It lasted 3 years, so yeah, we didn't do nothing. We developed and applied the best, we think, the best available scientific methods and tried to harmonize them. And made an openly available toolbox, which we applied and tested in the case studies of the project. The idea is we have very nice theory and methods from scientific literature, which we want to show how it works in the real world. And in this overlap, we see our project. Which tools have we developed? If we follow the ISO phases, because Aligned is very much related to LCA. So we have developed a method for generating dynamic background data for prospective LCA. And prospective LCA, that is a method where you change the background data to reflect future developments in, for example, renewable energy. So when you change that background data, then you get an idea about what will your technology do with respect to the environmental sustainability in the future. Especially interesting is this for new technologies which are not yet on the market, or for technologies which have a very long use phase. We have a method for identification of market constraints. That is, of course, we are working mostly with consequential LCA. And then you need, of course, a marginal mix. You need to know what the market does. So we have a method for identification of the biomass markets and the constraints which are there. I hope Damian will tell something about that. We're working on time and space dependent carbon accounting. That's certainly what Damian will be telling. And we look at dynamic assessment of climate change. And yeah, we did look a little bit less on biodiversity. Uncertainty and sensitivity analysis is often done already and typically done in LCA analysis. We looked at the various methods and we also improved them, also applied them. And we looked at socioeconomic assessment. That is a little bit not so much does it fit in the rest of the framework, but we also looked at that. All these methods are open access. They are all available. We have written tutorials to facilitate the easy use. We have made a tiered approach in some methods so that if you want to use these methods with not too much effort, and you can use the tier 1. If you want to have a more full method, you use tier 2 or even tier 3. That is to facilitate the easy uptake and the easy use of the methods, because in earlier interactions we found that many people were mostly concerned about that, had the applicability of the methods. So it's open access with the tutorials. It is a Zenodo. This is the link. You can use it, and we very much like your feedback on that. You are welcome to try the methods, and we would like to hear from you afterwards. We have a QR code where you can give your feedback. We very much appreciate that if you do that. Then the case study. We tried some of these methods in these case studies, and the case study which Damian will tell about is about the insulating foam of the company Kingspan. They use phenolic components in that insulating foam, have fossil phenolic components, and we have looked at the replacement of part of those phenolic components with bio-based materials. Yeah, it is Damian will tell really more about it, but we look at the way how we can replace the petrochemical phenols by biomass lignin, and we can replace the phenolic components by bio-based phenol, which is made from the vegetable oil. We'll see what will happen, and that's the case of Damian. What we are doing here especially is, and we are very happy that you are in this workshop and are able and willing to provide this feedback. 2 years ago, we reached out to gather feedback on environmental sustainability in the sector and the methods to be used. And nowadays we would like to present the results and to gather the input which we will use for our recommendations towards our policy recommendations and our recommendations towards the sector. Yeah, I hope you have a very nice remainder of the workshop. And yeah, I would like to thank you for your attention so far. Just one last thing. We have a stakeholder network where you can be informed with respect to the rest of the things which we do and the results, and of course a website, etc., etc., etc. So thank you. And I think I can give the word to Damian, who will tell something about the construction case study which he conducted. Damian, you're ready to take it away?
Yes, thank you, Patrick, for this nice overview of the Align project. Very fascinating discussions among us, because we can see all the, as you mentioned, all the similarities and also the specificities for each sector. And well, I could say that this is a general aspect of LCA practitioners to be able to match the specificities while staying somehow generic in the application of the tools, so that we can lean towards more universal methodology, I would say. May I share my screen? Yes, I can. That's good. Okay, I will launch the presentation mode. Hope you can see it.
Yes, we can see it.
Okay, thank you, Rachel. So, as Patrick mentioned, the case study for the construction sector workshop was performed in collaboration with Kingspan. I could see Bertram Santinger from Kingspan Company among us. So good to see you. And this case study is related to one of the major product of Kingspan Company, which is an insulating board made of phenolic foam. And yeah, let's dive into the presentation. Just a few words about the ambition and strategy of Align as an introduction, then description of the case study and how we can go towards getting bio-based, using bio-based resources. A few words about consequential LCA and specificities of this methodological approach, and yeah, try to look into details of the results while keeping them simple for interpretation, and a few takeaways for you today. So the overall ambition and strategy of Align, as Patrick mentioned, is to try and bridge the gap between what is done, what's the current state of the art in LCA science and environmental science in general, and what is currently done in the real world by practitioners and industries and governments, because there are gaps, and yeah, it becomes urgent to bridge them and to streamline the use of environmental assessment. On the right hand side of the chart, you can see the overall structure of Aligned, in which the first work package is dedicated to methodology, and other work packages are case studies for different sectors. And yeah, work package 1 has a lot of topics, and I'm going to illustrate today a few of them, especially yeah, what we call constraints to biomass, and time explicit climate change impact assessment, and a few examples of uncertainty tools that have been put forth during the project. So our case study, its name is Cool Term K5, and it's insulating boards made of mostly phenolic foam, and especially designed for external thermal insulation, used in what we call composite systems, meaning that several layers are necessary for the good thermal performance of the building, and this phenolic foam, this insulation board, is one of these components. It has been already the subject of environmental product declaration, which has shown that out of the whole life cycle of the product, one of the major components, contributor to the environmental impact in general is the phenolic resin. Well, it makes sense because it's the major component of the product. And this phenolic resin, and especially in the phenolic resin, the fact that phenolic resin is made of, is a polymer produced from phenol and formaldehyde, and the phenol part, well, formaldehyde also, but both come from fossil resources. So the question raised by Kingspan at the beginning of the project was how to switch to bio-based resources instead of fossil resources. And is it technically possible? What are the different options, and what would be the outcomes in terms of environmental performance? Yeah, I will just give a few insights into the chemistry very quickly. This is how the phenolic resin polymer looks. And this is the chemical structure of lignin. And well, just to show that we can see some similarities between these two chemical polymers, but also some differences. There were a lot of experiments at Kingspan to try and use purified kraft lignin, which is a residual material from the pulp and paper industry, and directly pour it into the phenolic resin and try and have it reacting, have them reacting together, and see what would be the outcome. They found out that you can substitute up to 25% of the phenol compound, of the polymer compound, and keep the same mechanical and thermal performance of the final product. But this is a ceiling. This substitution rate is stopped, and after a lot of experiments, they didn't achieve higher scores. And okay, there are other options to try and go into bio-based technological routes. And one of them would be a general depolymerization of the lignin polymer to get simpler molecules and ideally simplify these molecules into pure phenol, so that here, well, it's the same molecule. So we reach what we call a drop-in situation where 100% of the bio-based phenol can substitute 100% of fossil phenol. And this route is generally referred as lignin first approach, where we can oppose the notion of lignin last approach or lignin as residue, when you get some leftovers from other industries and lower grade of lignin and try and incorporate it in the product. Yeah, these are important considerations. Of course, there are a huge number of lab experiments and pilot scale experiments for both approaches, and so many that it was purely impossible to encompass all of them, and only a few were studied. We decided to study only a few of them in depth instead of having a broad view but coarse view of what can be done with lignin. Okay, I will open a parenthesis on the consequential approach of LCA, and also some differences between attributional and consequential LCA. These are notes from a commonly agreed, aligned conclusion. It wasn't the scope of a line, it's just a personal opinion, just to clarify a little bit the concepts and the approach. I know that in the construction sector, where EPDs are becoming increasingly mandatory, the attributional approach is used, and that's because, in my opinion, it's more relevant for a product declaration, while the consequential approach would be more relevant for decision-making, long-term strategy of a company. So it matches perfectly our question, which is how can we, or what if we substitute fossil phenol by biophenol, for example? And one of the differences also maybe important here are related to some technical specificities. We know that in attributional LCA, when you have multiple output processes in your system, then you mostly use allocation, and I can say most of the time economic allocation is the most common method. System expansion can be used. It's not a problem for that, and it's typically used for the products end of life, when you have some recycling or energy valorization of the used product. So we can see this, but in consequential LCA, we use only system expansion, and we take co-products as an integrative part of the system, because consequential LCA aims at assessing the consequences of the decision and describing what changes in the technological and environmental flows because of that decision. What are the positive outcomes and what also are the drawbacks? While attributional LCA is more fit to actually describe an existing system and to make it as precisely described as possible, so that accounting is made possible, product declaration is made also controllable, and you can monitor the evolution of the existing system across time. Okay, so now let's get back to our case study, and first application of one of the Align framework and tools is the availability, the constraint to biomass availability. I put the link here directly to the Zenodo page, where you can download all the tutorials and guidelines and tools related to this method. And this is, a typical consequential approach to use a decision tree to understand how the resource or the technology is constrained or not. And it changes a lot, because if you remember, the goal of consequential LCA is to assess the changes generated by a decision. And if for the source, biomass, for instance, is constrained, meaning that it cannot react to a change, then it would be treated differently as if it's unconstrained, meaning that it can react to a change. Let's take the example here. The first question is the feedstock a determining product of the process that generates its feedstock? Well, kraft lignin is not, because it's a byproduct of the pulp and paper industry, for which the determining product is the pulp, and it's constrained. And the next question is there a market? Well, somehow yes, today, because kraft lignin is used as a fuel to supply the demand of the pulping process, the kraft process actually, in heat. And I don't know if you were of that, but pulp and paper factories are actually producing extra energy, and this extra energy is converted into electricity and put on the market. So in a word, kraft lignin is a byproduct with a low value today. So it's used as a fuel, and in this sense, it finds a market where electricity can be produced out of it. While on the other side, the lignin first approach would be considered as determining as lignin would be the determining product and lignin derivatives, because as the name mentions, well, the first outcome of such technologies would be to retrieve high quality lignin or fractionated lignin that can be used after for further uses. So here we can see already different approaches that would be treated differently in consequential LCA. As I mentioned, there are a lot of possible technological routes for both approaches, and unfortunately, because of time constraints and resources constraints, we had to choose which one to dig into. And well, we decided to focus on the long-term scope, meaning what if we go really serious about producing phenol and phenolic compounds at large scale and in the long term, then we cannot focus on the constrained resources. We have to give priority to the unconstrained technological approaches, for which bio-based phenolic compounds are the determining products. And there are also here many technologies under study, often with low technology readiness levels, so meaning still at lab scale or pilot scale, but not deployed at the industrial scale. So there is a need here for modeling and projection to future state of the techno-economic system. We really are here again in the prospective approach and what would be long-term impacts of taking the decision of going bio-based. Okay, let's dive into now our study system and a few scenarios that we studied. We can see in general here the 4 main life cycle stages that are typically taken into account. What are the resources used and how they are extracted, transformed into the main product, which would not be the resin, but the outcome of the resin, the phenolic foam, then transformed into the final product, the insulating board. Then this board is mounted, and the use phase here is quite long because insulating material is typically put in place and supposed to be operational for half a century. That's somehow convention in the construction sector. And the end of life, what happens when the insulating material is used up or considered used up and dismounted, and what do we do with it? Several options also are here possible. When making life cycle assessment, we like to transform this figurative view into what we call a process flow diagram. And here the 4 colored boxes reflect the 4 main stages. So phenol production, manufacture of the K5 board, use of the product, and end-of-life scenarios. And we can see here what happens when we are into a system expansion approach. We consider the co-products from the biorefinery, for example, or some waste or that byproduct from different life cycle stages, or the end, and also from the end of life, what is done with them and what does it substitute? Does it substitute energy products, material products and what then what activities would have been displaced, impacted by this additional product and energy put on the market. I will now dive in even more into this biorefinery guy, because there are several options that we considered here, and I will focus a lot on these options for the rest of the presentation. The first approach, then you can see that it can become easily complicated and a bit messy, because all these white boxes are individual processes that can be gathered into, well, typical stages, and the process flow diagram starts with the production of biomass, harvesting and transports, and downs to be pre-treated, and the core process happens here, where some co-products are generated. Here, biochar, for example, and also some gas fractions. And the product of interest here is then refined to retrieve phenol, pure phenol. And some of the co-products, like some gas and the crude oil leftover, can be used in, for example, CHP units to be converted into combined heat and power. Okay. Someone has a microphone open. If it might be possible to close it, unless you want to raise a question, of course. Now, a second type of biorefinery is based on the process called reductive catalytic fractionation. We can see that there are a lot of successive steps to convert the feedstock, biomass feedstock, grown on purpose, into phenol. And here also, each stage delivers some co-products that would lead to substitution on the dedicated market. And that's another variant for the biorefinery, where instead of converting this large co-product fraction into ethanol, we convert it into heat and electricity also. We can already guess that since for 1 kilogram of phenol we produce 16 kilograms of pulp, then the fate of this co-product might have a major influence. And well, the fact is that in a certain amount of wood, not 100% of the biomass can be converted into phenol by fractionation, because only a small fraction, typically between around 20%, depending on the species, of course, 20% of that biomass is actual lignin, and only and lignin is not composed of pure phenol; it's also composed of several other elements, which means that in the end, only a small quantity of phenol can be retrieved from this. Okay, let's look into some results.
Yes, and just a heads up, we scheduled around 5 more minutes, but you can take the time you need.
Yes, fine. Thank you, Rachel. These are the results typically presented in life cycle assessment. Selected 6 impact categories, and for each of them, you can see the orange bars correspond to the different approaches for phenol. I can zoom in a little bit. Yes, like this. So you can see fossil phenol and the RCF phenol with ethanol as co-product, and the RCF phenol with fuel and combined heat and power co-product, and compared with fossil phenol. Then the dark blue shade is dedicated to the whole production of the phenolic resin and the phenolic foam, and the use phase, which is quite passive here. And the blue bars are related to the different scenarios for end of life, whether it is used as a fuel and then as material additive in a cement factory, or is it recycled into different kinds of products. These are real case studies delivered by Kingspan, while for the bio-based phenol parts, these are more the results of our model. So we can see here already that there are a lot of the phenol has the largest contribution and the highest sensitivity, I would say, in the overall life cycle. The orange bars are larger. There are a lot of variations and trade-offs between the impacts for phenol production, and it's kind of difficult to say here which would be the best alternative for among the studied ones for bio-based phenol. Let's look into the bio-based, the phenol production options. The same midpoint indicators are shown. We can see for the first impact category, climate change, that we have negative light blue bar. These are related to the cultivation of biomass, so CO2 uptake when the trees grow. Then these light orange part are indirect land use change. We can discuss them a little bit, mostly generating water pollutions and air pollution. The violet bar are related to the energetic co-products, meaning that they are interesting for the impact category. They are not, interesting to look into for the particulate matter, air pollution, and substitution of fossil resources. And also brown here category for the material products. Typically here we can see that large impact is related to the ethanol co-product, but also large avoided impact when it comes to eutrophication in marine ecosystems. Of course, I can dig into the details of these results and explain them after, but I still have a lot to show, so I need to hurry a little bit. So trade-offs between impacts, it's very difficult to see here what would be the best option to go for. The co-products have a high influence and generally lead to avoided impact, but not always. And when we compare with fossil phenol, the fourth option, then we can see that we have, in general, better results for climate change and fossil resources, but we have higher impact when it comes to air and water emissions with the bio-based routes. The black triangle is just the net sum of all the life cycle stages. Okay, another tool used and delivered in the aligned repositories is the use of time dependency to assess climate change. If you want more details into this, I invite you to look into the methodological workshop held 1 month ago, in which I presented into much more details than I can here. Just to explain that with a tiered approach, we try to help users in a stepwise guidance towards current practices into complexity and how to handle this time dimension in climate change, which is actually quite important, as we will see in the results. The tier 1 is just here to help starting and to define which life cycle phases are important and what would be their temporality. Yeah, just a small important point. In consequential LCA, we look at the future consequences of today's decision, meaning that we cannot look at past emissions and uptakes because they are not influenced by a decision that would be taken today. But it means that if we decide to go bio-based today, we need to take care of the regrowth of the hardwood or softwood we would be using for the production of feed oil. And this is clearly something we can see with when we put timed emissions into a chart. These charts display simply the use of static characterization factors just to exhibit what happens in time with carbon flows. The high peak at the beginning is due to manufacturing of the product and also of co-products, and what is the fate of the co-products, assuming they are used quickly, such as pulp is used as a fuel, for example. That would be done today. Then we can see here a descending curve highlighting the regrowth of a tree. A small bump here related to the end of life of a product 50 years after mounting and use, and then the decay and net emission of CO2 here shows that the wood debris that are not harvested also are taken into account. That's thanks to the other foreground tool for dynamic carbon flows in bio-based activities. Okay, so we can see that there are greenhouse gases flows for more than 100 years. So time matters. And well, we are here, two climate change indicators are used with different time horizon. And simply the interpretation here, since the two curves are very close, is that mostly CO2 is responsible for the emissions and uptakes. And when we add the time-dependent emission factors, we can see that the curves, especially for global warming potential at 100 years, is much different. And this is due to the fact that future emissions occurring here have less impact on a 100-year time horizon. So in the warming in 100 years than emissions produced today. And so it illustrates also that how the global warming potential at 100 years focuses on gives more importance to short-term effects than long-term effects. Sorry, I need to get a bit faster. Just
yes,
to
as you said,
mention
that time is important. Are you okay to start wrapping up?
Yeah, yes, I will have just one last comment here and maybe skip the uncertainty and sensitivity analysis part, which will have been just after. Yeah, just to show here that the cumulated effects on climate change over time becomes negative only after somehow 30 years, meaning that all the emissions generated by the biorefinery mostly and what is done with the co-products are somehow compensated by the tree regrowth. It takes 30 years to compensate these short-term emissions. But then after, we can see that the overall balance is negative. So yeah, it gives a finer interpretation of the results in terms of climate footprint of such a product. Okay, sensitivity analysis, you will be also able to use the guides and stepwise approach for determining uncertainty and sensitivity of what you modeled, the data you collected. Few examples here would have been on the one at a time approach and global sensitivity analysis. One at a time means a lot of parameters in the model, and if I move one to by 10%, what is the impact on the different categories? And yeah, here we can see, for instance, that for the ethanol part, a lot of parameters are highly influential, while in the paralysis part, a lot of parameters have low sensitivity. And yeah, for the global sensitivity analysis, the orange part is the ethanol, the blue part is paralysis. And we can see here that also for paralysis, you have much narrower ranges of results, which means that more certainty, or yeah. So we need to say that would be probably the next step in our work to see what are the differences in our modeling approaches to merge them. We have been using two different brains to model these two biorefineries, so it would be nice to confront and merge them. So as a takeaway, if you are into long-term strategy or decision making, we recommend to use consequential LCA to make sure you encompass the whole system of the whole consequences of the decision. Be careful when you want to go into bio-based resources because they are limited. We have plenty of residual biomass, but they are constrained by definition because they are residues of other sectors. And on-purpose cultivation involves land use change somewhere else, involves also sometimes long-term recovery and carbon uptake when specifically wood is used. When you want to look into biorefineries, it's important to consider all the co-products and what they would substitute, and make sure that all the co-products substitute only fossil resources. Time-explicit climate change, a tier approach can help you identify if it matters or not for your product, and also help you identify what are the prerequisites to make sure that the net overall benefit is there for climate. And you also could see that some tools dedicated to uncertainty and sensitivity, of course, are model and data dependent, but they also give an additional light into decision making to make sure that all options are considered and decisions are secured. Okay. Yeah, I hope you enjoyed the presentation, and I'm ready to answer questions or get back to some details if you want. And yeah, sorry for the bit longer than expected presentation.
Yeah, sorry. Thank you, Damien. It was really a very dense presentation. Hey, you showed really quite extensively what you've done. You really worked very hard on it. Some things were not always fully clear. To me, especially for example, the various technologies and how well they performed with respect to environmental sustainability, the various options. But you showed very much and very interesting ways in which you handle issues like the dynamic carbon allocation and the global warming potential. If you change the window, what happens there? So quite interesting. Thank you. Is there any question or comment on this? No?
Then I hope people are excited to interact a little bit, because it is your time to speak up now. Because we are starting an interactive discussion about these methodologies. And we will do that via an online tool. So you can scan this QR code with your phone, or you can go to the website. It's called ahslides.com/construct2. And it will work like this. You will scan it and then you will go directly into the application. And I will keep the QR code in the screen. First, we will go to do some trial questions. And it's just to see what is the audience, where are you guys coming from, yeah, to get some interaction. So the first question is, what is your field of occupation? And if you have any problems, also just raise your hand or put it in the chat, and we can connect.
Yeah, and you the idea is that you click on one of the icons and then scroll downwards, and then you click on the button submit.
Exactly.
So just clicking on it won't do it.
And we can see for now 6 people entered and 8 people are already in the application. So it's good.
Yeah.
We can see we have some people from research, which is interesting because as we said in the beginning, we also did a consultation online where we also had a lot of people from industry. So it's good to compare to see what different groups care about in these LCA methodologies. Okay, I think for now I will continue to the next question, but it's good to have some insights. So this is a question where you can type in, and the question is, in which country are you located?
Saudi Arabia, interesting. Yeah. Spain.
We can see very diverse group today.
Portugal. Yeah.
Yeah, it's nice. Then we have a good overview. And it's nice to see that it works.
The Emirates. Okay. Interesting that there's so much interest in construction sustainability from that region, apparently. Yeah.
Yeah. And then the first question that we also use in our consultation, it's more general question about what are current barriers to perform an LCA. And while people take the time to fill it in, I can show you what the consultation had as answers. So a lot of people, they voted on data availability. We see this time and time again for different sectors. I think in LCA, it's quite often you encounter problems with data availability. And we see that the costs are not often a problem. And now let's see what today people are saying. Okay, so again, we see data availability. It's a quite common barrier. And for the professional skills, of course, we are already before mentioned that maybe it helps written guides from the Aligned project, if you are interested. Also in applying the methodologies that we talked about today. And if somebody wants to elaborate on their decision, feel free to raise a hand also, or always open your mic.
Yeah. And you can also use the chat if you have questions or comments.
But I think for now we can continue to a next question, which is which guidelines do you use for performing the environmental impact assessment? So
Yeah, and the text is a little bit small, but from left to right, it's standards like the eco-label PAFC or the FSC, environmental product declaration, product environmental footprint, the biogenic carbon content calculator, the ISO norms for LCA, and the carbon neutrality biogenic carbon EN 16485. Okay, it's used. Interesting. Yeah. And the EPD, it's used often in construction.
yes.
It's very established. That's what we hear from all sides when we talk to stakeholders in the sector.
Yeah.
Yeah.
And today we can also see that EPDs are strongly there, and the ISO norms also always a basis of the LCA.
This is also a common picture from the other sectors. You see that mostly LCA, the ISO norms are used mostly, and other things are always used more to a bigger or smaller extent. And also the PEF we see more and more turning up.
Okay, thanks everybody for filling it in. I will skip some questions so we can later in the end go more specifically into the aligned methodologies. But I would like to ask these questions about what are usually the primary sources of data when performing an LCA. So from left to right, I can read it aloud. It can be internal on-site data, general background databases, sector-specific databases, scientific papers, and expert consultations. And then if we were take a look at the consultation, we could see that internal on-site data and general background databases were the most common primary sources of data. And also some people, they said that it can be a challenge.
I think it will be likely for many people the case.
Yeah.
Yeah, it's what is remarkable from my idea is that the sector-specific databases are not used that much. I would expect that in the construction sector there are quite some elaborate databases for determining life cycle data, for finding life cycle data, but apparently not. It's said it's from the survey, and also here we see not too many people using them.
Yeah.
If I may add something on top of your remark, Patrick, I would say that depends on where you are in the production chain or in the construction sector. If you make buildings, houses, then you would use sector-specific information, but more EPDs from the material suppliers. But if you produce windows or roof tiles or insulating materials and so on, there are so many types of materials and suppliers that it's more likely that you need to rely on general information. Regarding the question raised, maybe it was for me. I was thinking of the INES database that's in French, where a lot of construction products are referenced with their own EPDs called FDES in French.
Yeah,
Okay, thank you for the elaboration.
And in the Netherlands, we have, for example, the Nationale Milieu Database. That's also a national database with information related to the construction sector.
Okay, and then back to the dynamic carbon accounting. We can see everybody was voting that they look forward to the methodology, which I can already say it's quite different than what was responded in the consultation. Actually, there the votes were a bit more distributed, and some people were actually not sure if they wanted to use it or how to view it. So it's good that people today got more information and they got interested in it.
Mm-hmm.
Then the question that is immediately linked to this is, what kind of problems do you foresee if you would use this? And we can take a look, at the consultation. Yeah, we can see that people voted. Yeah, it's quite distributed. Not one clear answer that it's the problem people think they will encounter, but it can be the incompatibility with existing standards, which makes sense if it's not already described in the standards or applied.
And not too many people are afraid of the reliable data.
Mm-hmm.
I would expect that it could be a problem, but apparently other things are more of a problem. That's the incompatibility with existing standards. I think it is construction sector, the EPDs. Dynamic carbon accounting does not work very well, I think. So that's, to me, understandable.
Okay. Then our next question focuses on the consequential LCA methodology.
Yeah, may I just have a question to Damien? In your work and your use of the dynamic carbon accounting, what is your view on the availability of data for your case? Was that very difficult or relatively easy, or?
Now you don't need any additional data for the time explicit climate change accounting. You just need to figure out how to identify for each life cycle stage what is the temporality, and then simply applied the tools. We have a whole grid with the emission of methane in year 23. We'll have this characterization factor for global warming potential. So yeah, the most difficult approach is the trickiest part that is different from streamline LCA is to assign a date to each emission.
Mm-hmm.
And the tiered approach displays helps you going into this skill. The first tier would invite you to split your life cycle stage into 4 basic parts and assigning a reference year for each part. And then in the tier 2, you can fine tune this and make a time distribution for each life cycle stage. But yeah, you don't need any additional data as what you already collected.
Yeah, well, you need a little bit about the timing of the stages, and yes. Are there some guidelines given in the manual on how to define the length of these stages?
No, it's really normally when you put a product on the market, and you already have performed the LCA, you are quite able to identify the time range for each stage. And what we could see also in the application of this method is that it really matters for long lifetime products, but it matters much less for short lifetime products. So when you rely on
short is 1-2 years or something, yeah?
Yeah, less than 5 years, I would say. And but like in our case, it was not possible to find fine-tuned estimation of the lifetime of an insulating product. So we set this as 50 years because it's a rule of thumb in the construction sector. And for the biomass growth, we know it is trees. And in the first year, I just simply put the assumption that the rotation time for this tree cultivation is 40 years, quite randomly, based on expert guess, I would say. And then I could see it matters in the tier 1 results. So I went one step more into details and use the aligned tool sets for time explicit and really fine-tuned carbon CO2 uptake and emissions for wood cultivation that is also available in the repositories. And then I just had to make a couple of clicks and I had my whole profile of emissions and uptakes in Excel format. So at least if I don't have the details and I need to model a cultivation of tree species, you can simply use this tool. Question in the chat is where can we find the aligned toolbox? So
if you scroll upwards, you can see a link which was posted by
Rachel, yes.
By Rachel. No, it's about the methodologies. Yes, the most upper link, you can find it.
Yeah, and you have all the details on framework for impact assessment, for biomass availability, uncertainty, dynamic carbon accounting, and also other things I didn't work on, but like background life cycle inventories and also the recorded webinars can be a useful material for to start working with them.
Yeah, they can all be found on the Aligned website.
Okay. Yeah, let's go to the consequential LCA versus the attributional LCA. Many people look forward to using a consequential LCA. Only 2 have another opinion. Of course, if you want to put in the chat why you have this other opinion and what it is, then we are very interested to hear. Yeah, it's interesting. Is that also the case for the survey which we did earlier? We had the same questions, of course, in the survey earlier. And there it was a bit more mixed, I see.
Yes. So if people voted 1, it means they are not likely at all to use the consequential LCA methodology. And we can see it's a little bit more shifted towards that they are not likely to use it. And I think this is highly related to the EPDs and the fact that the EPDs prescribe attributional LCAs. So they do not leave room to use the consequential LCA for an EPD.
Yeah, and that's a very hard no from EPDs. Yeah. Okay, yeah. Well, if you are doing EPDs, then you cannot do anything else than use attributional. Yeah. Okay.
Yeah. Once again, as I mentioned, also, and maybe it would be helpful for hopefully for LCA practitioners to understand the complementarity between the consequential attributional approaches. Yes, product declaration is a way to describe what has been done for an existing product on the market and what is the currently producing system. While the problem is that attributional is often used for decision making, and that is misleading. Can lead to wrong decisions, especially if you are into bio-based products which are flow limited, and there is competition for this resource in many sectors. So yeah, using these resources will have necessarily consequences on other sectors, and that needs to be considered in a more general way if you want to follow the LCA rationale and purpose. So both are complementary, and that's fine for this. But yeah, for product declaration, then it makes sense that in a way that the regulations mostly base their guidelines and standards on attribution.
Yeah, Damien, just when we're thinking about this, the use of attributional versus consequential. With consequential LCA, you are using a market mix, and of course that is also determined in a point of time. It is after a few years, it may be different.
Yes.
Isn't that an additional issue with respect to consequential LCAs?
Yeah, it can bring surprising results, and but it's true that you will have an impact on what is able to change, and so unconstrained processes and systems. So, but that's always the difficulty when you look into what's coming ahead, and when you try to model this, there is also a lot of uncertainty. You need probably several scenarios depending on what you are working on.
Yeah, no, it's maybe just a related question. We were a related issue. We were looking, for example, at the technology which could reduce CO2 emissions by capturing CO2 and using it.
Yes.
And if you look at it from a consequential way, it's very difficult to determine actually how much you are actually saving in CO2. But if you look at it in an attributional way, it's very clear and unambiguous. You are saving this and this amount. And yeah, especially if you are, of course, making policies, it's clarity and treating everybody the same is a good thing. And sometimes with attributional, that is possible. You allocate, you attribute, and it is the same for everyone.
Yes,
and with consequential, that's more difficult.
Yes, in attributional, you partition the whole emissions made from mankind in 2025, and you distribute them. You distribute the responsibility. So you need normative choice to see to which actor that this or that emission, this or that impact is related to. But it's fine. We need to have these tools for accountability and yes. On the other side, for the consequential approach, you try to answer questions like, what if I change this or that? So it's not a question about how to partition the existing impacts, the already made impacts, but what would be the consequences of going into this or that. Maybe I can give also a contrasting example for the studied biorefinery. We can see in the RCF refinery, we have a lot of pulp as a co-product, and because it makes part, it's the largest part of the biomass. And what do we do with this pulp? If we want to valorize it as ethanol, maybe, which was one of the scenarios studied, then you will, in the end, put this new ethanol on the market, on the global market. It's a global market, ethanol. And what would it affect? If we look at the long-term changes of this decision, we would enter in competition with expected production systems of ethanol. And these production systems of ethanol are based on sugarcane cropping, cultivation, and transformation. So it means that if this pulp is converted into ethanol and put on the market, it will displace the production of sugarcane ethanol. So it will reduce the amount of sugarcane cultivated, and thus it will prevent CO2 capture from this sugarcane growth. So we have displaced effects somewhere in the world that would need to be taken into account. And it's not a question about who is responsible for this or that emission. It's a question of what are the consequences, direct and indirect consequences of the decision I wanted to take.
Okay.
Interesting. Yeah. Rachel, indeed, we need to continue. If the EPD is sufficient, many people say no. It would be great if people can say why they think the EPD is not a sufficient tool for environmental impact assessment.
Yeah, I do have some examples that people left in the consultations. Like,
Can you
for
show them?
example, some people described that EPD did not focus on the recycled content or did not show the entire big pictures, or that the EPD did not support bio-based decisions by not including biogenic carbon. But also a lot of people voted that an EPD is sufficient because it's easy to understand and it gives the possibility to compare some products. So I think it's interesting if you think about the field of LCA, the usability versus the precise or how,
Yeah, no, I think both these things are right. There may be issues, but it's also easier to compare, and it is easy to understand. So yeah. If anybody wants to say something on the chat about this, it's they're welcome too.
Yes, and I think then we should go to a final question because we are in the final minutes of the workshop.
Yeah.
And I would really like to know what methodology that you were introduced to today would you look most forward to being implemented? And I can already show some results from the consultation. Yes. So there we could clearly see that the green bar, it's the one that shows where people look most forward to. And we can see most people voted that they would really look forward to the prospective LCA method.
Okay. Yeah, and the prospective LCA method is the method where you change your background data for the future. Just a quick question to Damia, if I may. You didn't use it. It's would that have been sensible to use a prospective LCA approach in your case? if you would have infinite time. Huh? Can you say something about that, Damien?
We actually, were not using the tutorials and tool sets for prospective LCA that are in the aligned toolbox. But we, in a way, had also to have some considerations about what are the possible scenarios in the future. For example, because as maybe you remember from the process flow diagrams, we have a lot of fuels and energy co-products, and we need to project ourselves in the future because these biorefineries do not exist yet, are not yet operational, are not yet even built and optimized. So we need to put ourselves a little bit in the future to see what would be the consequences of such a biorefinery. So we had to find information to model the probable marginal mix for electricity, for heat, and there are different kinds of heat depending on the temperature demanded, the requested temperature. What will be the future production of hydrogen, because it's highly important in the reductive fractionation. It's one of the main reagents with the biomass. So we had to do a little bit of this exercise, and we, in a way, we didn't work with already existing tool sets of prospective LCA, but we kind of run some sensitivity analysis of this or that scenario for hydrogen or heat, for example, because we have no crystal ball, so we cannot know what will be the production systems for electricity in the Netherlands in 15 years. So in a way we did it, and we could see that it has some influence on the results. Definitely.
Interesting. Yeah, it's nice that you did it a bit yourself without the toolboxes. I think we have come to the end, Rachel.
Yeah, exactly.
We took some more time for the work of Damien. I think that was very nice. It was a very meaty piece of work, so that requires the time. So thank you very much for that. I like to thank everybody for their inputs. We really appreciate it, and we will use it in our recommendations. We will share the proceedings. You will get emails where you can look at the recordings, etc., etc. It was very nice, very interesting. I would like to thank Damien for your great presentation. I would like to thank Rachel for the very good organization. Thank you very much. I already thanked everybody else. There is an invitation to join our stakeholder network. And as I said, I thank you very much for being here, and we hope you enjoyed it. And I would say have a very good morning, afternoon to all of you. Bye.
Yes. Bye.
Yes.
Thank you.
Thank you, Patrick, Rachel. Thank you, everyone.
Thank you.
Have a good day.